Now, in this video, we are going to understand how replication works in MongoDB and why we need replication in our databases. So first things first, I'm going to just maybe have a title here, and let's call it replication in MongoDB. Now, MongoDB is a database we all know, and it's a NoSQL database, which means the schema is kind of flexible, and you can actually change the schema as the requirements for replication changes. Now, usually a deployment of MongoDB can be one instance. Let's say this one here is our server that is hosting MongoDB database. So let's call this MongoDB1. DB1. So when you have a single instance or a single deployment of MongoDB, then it means all the writes and reads are all happening here in the same database. So when we talk about writes and reads, all of them will be done in this single instance, because this is what you have. All the reads and all the writes will be directed to this single server. So let's say here we have reads and writes. Okay. So this is your application. So you can have something of this sort. So this is your app. So this is your app here. Now your app maybe it's an application where you want to store customer records, and at the same time you will be reading customer records, or you're reading orders from your database here. Since we only have one deployment here, then it means all the reads and writes are happening here. Now this works for small deployments or in cases where data high availability is not such a huge concern. Especially think of it this way: if you're having an application that is having requests every second or every minute, then what will happen if this database goes down? Let's say this DB we're having here now goes down and it's no longer functional, right? So let's just assume this DB goes down, maybe because of network issues or server failure, or something is just wrong with the database here, or assuming the data center is down or a disaster has happened. So what will happen to your application here? What will happen is that you'll have a downtime, because reads will fail and writes will fail, because we don't have, or we didn't think about high availability from the word go. Now that is where now we bring in what we call a replica set or replication in MongoDB. So what is replication in MongoDB? So this is what happens. Initially, we have only one instance which has gone down, and now the application is down because we have no reads and we have no writes, because everything is happening here. Now, what will happen if we have now what we call a replica set? Or now replication is coming into the picture. So what happens here? Replication. To replicate is to simply make a copy, right? To replicate is to make a copy. To replicate is to make a copy. So this means if I'm replicating, then assuming I'm having a server here and I'm having another server here, and let's label them, this is server A and this is server B. This is server B. So if I'm replicating, it means every action happening here should happen in server B. So if we write here, that same should happen in server B. If I update here, the same should happen in server B. So at any given point, we expect that data in A and data in B are identical, right? So we'll have something like this. Here we have replication. Think of it, replication. Just think replication and to replicate, to copy. So what we're simply doing is copying. So we're copying from A, which is the master server, and once A has confirmed that the write is okay or update is okay, then B will now initiate or start copying what we have in A. That is what we call replication in a layman's language. But now in the context of databases, let's understand how replication works. Initially, we have only one database here, or one instance, which is MongoDB 1. Now, when we now bring replication in the picture to replicate, then it means we expect to have more than one instance of the database. So in this case, we have 1 and 2. This was just an example. So let me show you how it is in our MongoDB. I'll scroll on top here, and then what we'll now do, we'll have now 3. This is our first instance of MongoDB, and this is another instance of MongoDB, and this is another instance of MongoDB. So these are just servers or VMs, and inside these VMs, what we have installed is the MongoDB server. So just think of this as just VMs, nothing big, or EC2s in AWS, right? So this is what we have here. Let me just duplicate this to just make it stand out. So this is a VM. This is also a VM. But now inside right here, we have MongoDB installation. So inside, what we have is MongoDB installation in each VM. Duplicate. So this is Mongo. Here we also have Mongo inside this VM. So think of it this way. Call this Mongo 1. And then this one also we have Mongo 2. Mongo 2. And lastly, we have Mongo 3. Right? So all these are now MongoDB instances. And now I want to illustrate how replication now happens. Now, ideally, in any given database, writes will only happen in a single node. For example, if we choose Mongo 1 to be the primary node, so Mongo 1 should be the primary node. Let's call this primary node. So why are we calling it a primary node? We are calling it a primary node because it accepts writes and can also accept reads, all right? Remember, at any given point, writes have to happen in a single server so that we can have a single source of truth. We can't have writes happening here, happening in here, happening in here. It has to happen in one of the nodes, and that will act as our source of truth, which in this case is MongoDB 1. Now this is the primary node. And then now we have what we call secondary nodes, which is now Mongo 2 and Mongo 3. So these, we call them secondary nodes. Secondary nodes, right? So I'll just copy this again, duplicate, and there we go, secondary nodes. Now secondary nodes, what they do the replication. How? They will always copy what is happening in the primary node. So in that case, what we need to have is a way in which they will communicate. Like Mongo 2 can communicate from primary, Mongo 3 can replicate from primary node. So how do we do that? Let's assume now we have some kind of connections happening here. Let me see if I can put this as a dot. I'm not even sure how to change it to a dot, but anyways, as long as you can see there's a connection, and then this also can have what we call a connection to that. And then Mongo 2, all the secondaries can also communicate with each other. Sorry for that. So we have primary node accepting reads and writes. And then we have secondary nodes, that is Mongo 2 and Mongo 3, which are storing copies of data from primary node. Now, here's what happens. Every 2 seconds, all these nodes will be sending heartbeat signals to each other. Look at this. So we have what we call heartbeat. Let me see if I can have... Okay, let's use this. Heartbeat is being sent here. Heartbeat signal is being sent there. And heartbeat signal also being sent here. So this, call them heartbeats. Let me just give you some key here. And we'll call these heartbeats. Heartbeats. So what are heartbeats? So heartbeats are basically signals being sent by each node to the primary node or secondary nodes to confirm if they are healthy, right? So for example, in a simple manner or simple terms, Mongo 2 will be sending heartbeat signals to primary, and if it sends it successfully, it means primary node is up and running and therefore it's healthy. Mongo 3 the same will send heartbeat signal to primary node. If it does that successfully, it means primary node is up and healthy. So every time our application, that is what we have here, it sends a write request. Let me show you. Our application will be sending write requests here. Remember, we have our app here. So here we are sending write operations. And also sometimes we can also send read ops operations, right? Depending on the configuration that you're having. So let me just move these ones here. Let me move these to the side. Not even sure if I can move them. Good. They can be moved. Yes. So any given point, our app will be doing the write operations on the primary node and also read operations on the primary node. And then the secondaries, their work is to just simply copy what we have in primary and in Mongo 3 and what we have in primary in Mongo 2. So why do they need to copy? Now this is the situation. Remember, initially we failed, we had a downtime because our single instance failed. Now in this case, if our primary fails here, then something happens. What happens is an election. Election happens when primary can no longer send signals to the secondary nodes. So in that case, it will tell the secondary nodes that primary is down, and therefore we need to elect a new leader. Now the new leader will be the primary. Now Mongo 2 and Mongo 3 will vote, right? So what is happening here is now called election. If primary is down, right? I want this to make sense. So if this is down, it can send heartbeat signals to secondaries. Then Mongo 2 and Mongo 3 will agree, right? Then primary is down. Let's now conduct an election. The election will decide either Mongo 3 or Mongo 2 will become the new primary, right? So roles will change, right? So we'll have either Mongo 2 or Mongo 3 as the primary. So in this case, now this is down out of the picture. Mongo 2 or Mongo 3 becomes the primary. Now, how do election happens? Election happens using certain algorithms, which we'll discuss in other videos. But in this case, you see now the problem we are solving here is high availability. Initially, when our single instance went down, our app was down because we could no longer do reads and writes. But now, since we're having a replica set, and at any given point, secondary nodes were copying data from primary nodes in real time, it means that if we lose the primary node, then election will happen, and of the two nodes remaining at secondary, one of them will be elected to become the new primary, right? So this can become the new primary, right? And then this will remain to be secondary. Now, while we troubleshoot as a database administrator, while we troubleshoot what happened in primary, once it is back and operating, it will find that it is no longer the primary because we have a new primary. So it will assume the role of secondary. Let me show you. So this will now assume the role of secondary node. And therefore, this will now instead send heartbeat signals to node 3 to see for any new activities or new data and copy them from the new primary, which is node 3, to its own MongoDB instance. Node 2 will still remain to be secondary by sending signals to now the new primary, which is node 3. You see how it changes? Initially, node 2 was sending to Mongo 1 as the primary, but since Mongo 1 is down and the new primary is not node 3, it will send signals where from node 2 to Mongo 3 for new write data or new entries in our uplog or our journal files. And that's just an introduction of how replication works in MongoDB. And so why do we need replication? Let me just tell you why we need replication. One, So why replication? Why replication? Why replication? So one is high availability. High availability. Number two is scaled reads. You can always configure that the primary only receive the writes and secondary is to handle the reads, so that we can at least relieve some pressure from the primary. Something else is durability of data. So durability. So in a replica set, there's something called write concern. So when we have write concerns majority, it means that even though data is returned to primary node, we want to ensure that it has already been copied to the other secondaries. Then it is until then that we count that as a successful write, which means a data returned here as copies across majority of the nodes. So these are the main reasons why we will need replication in our MongoDB deployments. So high availability, scaled reads, and durability. Thank you for watching this video. See you in the upcoming videos. Osego Codes signing out.